Imagine a hologram. It's a three-dimensional image, seemingly real, projected from a flat surface. Now imagine our vast universe operating on a similar principle. That's the essence of the holographic universe theory. This mind-bending idea suggests that everything we experience, from the stars above to the ground beneath our feet, might be a projection of information encoded on a distant, two-dimensional surface. This concept challenges our fundamental understanding of reality, proposing that our three-dimensional world is, in a sense, an illusion. The holographic universe theory doesn't claim that our world is literally a hologram. Instead, it uses the hologram as an analogy. The theory argues that the information content of a region of space is proportional to its surface area, not its volume. This means that what we perceive as three-dimensional reality might be encoded on a distant two-dimensional boundary, much like the information in a hologram is encoded on a two-dimensional surface. This theory, while still speculative, has profound implications. If our universe is a holographic projection, it could revolutionize our understanding of physics, cosmology, and even consciousness. It could rewrite the rules of the cosmos, suggesting that our universe is more interconnected and stranger than we ever imagined. The seeds of the holographic universe theory were sown in the 1970s and 1980s by physicists grappling with the mysteries of black holes. Stephen Hawking, a renowned physicist, demonstrated that black holes emit radiation, now known as Hawking radiation. This discovery posed a problem. If black holes emit radiation, they lose information, which contradicts the laws of quantum mechanics. Physicists Leonard Susskind and Gerard T. Hooft offered a potential solution by proposing that the information swallowed by a black hole is not lost, but rather encoded on its event horizon, the boundary beyond which nothing can escape. This realization sparked the idea that perhaps the entire universe could be viewed as a holographic projection of information encoded on a distant surface. Their work laid the foundation for the holographic universe theory, suggesting that our perception of a three-dimensional reality might be an emergent property of a more fundamental two-dimensional reality. Imagine a fish tank. The fish inside perceive their world in three dimensions. However, we can observe their entire universe, every movement and interaction, from the two-dimensional surface of the tank. The holographic universe theory proposes a similar concept for our reality. It suggests that all the information about our three-dimensional universe could be encoded on a distant two-dimensional surface surrounding us, much like the information of the fish tank is encoded on its surface. This surface wouldn't be a physical boundary like the edge of the fish tank. Instead, it's a theoretical construct, a holographic screen upon which our reality is projected. Think of it as a cosmic movie screen where our three-dimensional reality unfolds. Every particle, every force, every interaction in our universe would be a manifestation of the information encoded on this distant surface. Section 4. Echoes of a Simulated World. The holographic universe theory shares intriguing parallels with another mind-bending concept, the simulation hypothesis. Proposed by philosopher Nick Bostrom, the simulation hypothesis suggests that our reality might be a sophisticated computer simulation run by a more advanced civilization. Both ideas challenge our assumptions about the nature of reality, proposing that what we perceive as real might be a carefully constructed illusion. The holographic universe theory, with its concept of a two-dimensional surface encoding our three-dimensional reality, could be interpreted as a potential mechanism for such a simulation. The information on the holographic screen could be analogous to the code of a simulated universe, dictating the laws of physics, the properties of matter, and the flow of time within the simulation. While the holographic universe theory doesn't require our universe to be a simulation, the similarities between the two concepts are hard to ignore. Section 5. Clues from black holes and entanglement. Despite its radical nature, the holographic universe theory is not just a philosophical thought experiment. There's growing evidence from various fields of physics that lends credence to this mind-boggling idea. Studies of black holes, those enigmatic cosmic objects, have provided some of the most compelling support. As mentioned earlier, the information paradox of black holes, where information seems to disappear within them, led to the initial ideas of the holographic principle. Furthermore, the bizarre phenomenon of quantum entanglement, where two entangled particles remain connected and influence each other instantaneously regardless of distance, also hints at a deeper holographic reality. Quantum entanglement suggests that information might be shared non-locally, meaning it doesn't need to travel through space and time as we understand it. This non-locality aligns with the principles of the holographic universe theory, where information encoded on a distant surface could manifest as interactions in our three-dimensional world, seemingly defying the limitations of space and time.